Oh, wait, I thought I saw a chat message. Oh, yeah, yeah. It has a tendency to crash my Mac, but at least a few times it has done so. And I had to reboot my Mac because it completely froze it. It was able to find the video file. So, anyways. So we've talked about abstract classes, and an abstract class is something that, well, I mean, I guess you can make an abstract class with no methods in it, but one of the points of it is to make sure that it has methods that everything that below it has to implement. Not that it implements those methods below, but that the things below have to implement it. And so we're going to make an abstract class called vehicle. And maybe if I spelled vehicle correctly, why are you complaining? All righty. So anyways, so abstract class vehicle, and all it's going to have is a variable for the name. And then a constructor for the name. And this one, I can't even think of a reason that this has to be abstract. I'm not coming up with a great reason for that. So I'll leave that alone. This will be an example of interfaces instead. So what is an interface? An interface is an abstract class. Well, sometimes you wish that you could inherit from multiple classes. Like you wish you could create a class called 2D object and a class called 3D object, and then you could write a class that extended, that extended both of those for whatever purposes, or a drawable object on the screen and then a savable object to disk, and it could inherit from both. Now, C++ allows inheriting from two classes. However, Java does not. Java, you can only have one superclass. So your item can only have one superclass, and it's okay for that item to have a superclass and so on. Interfaces let you work around that. So our vehicle, we're going to define two interfaces for it. You can have interfaces with motors. Oh, now I think I can come up with a reason why vehicle needs to be abstract. And then you can have interfaces without motors. Lighters and things like that. And so every vehicle needs a move method. Otherwise, it's not a vehicle, is it? Now, since this is an abstract class, it doesn't have a body. Since it's got an abstract method, it has to be marked as abstract. And so everything that has a motor has to have something called, start, right? We have to be able to begin the motor. Engage, turn on. Yeah, turn on. So public void, turn on. And we're going to add a constructor to this. No, wait, no, we're not, because it's not a class. That's going to be our abstract method. Everything has to have a turn on. Now, if it's marked as an interface, everything already in it is an abstract method. So I don't have to put the word abstract here, although it doesn't hurt. You can do so, you can not do so, your choice. And so if it's motorless, I can't think of anything to give there. So you have to be able to refuel your motored vehicle. You have to be able to turn it on. And a motorless vehicle, well, you don't turn it on, you don't refuel it. What do you do with it? Tell you what, I'm just going to make this an abstract. Yeah, I'm going to make this one have be our interface as well. So it's an interface vehicle. And it's got a move method, right? Because everything that's a vehicle needs to move. It doesn't need a name. It doesn't need a constructor. And so every class that we make can have a vehicle interface, which is known as a contract. We're creating a contract that every class that we make from this will have a move method. And then we're deciding that everything that has a motor interface has to have these additional methods. So if we make, a jet airplane, it's going to have everything that's up above it. So it implements both of those interfaces. It implements vehicle and motor. It's got some kind of motor in it, or maybe I should call it engine, right? Whatever. And it says that jet is not abstract and does not override the abstract method move. True enough. Now, if I marked it as abstract, it'd be okay not to implement these things because we're saying that whoever inherits or, from jet would have to implement them. We'd have to pass the buck along, but we can go ahead and do so, right? So public void move. Just going to print a message that says I am moving. System.out.println parentheses quote zoom, right? Because that's what jets do. They zoom, they fly through the air, or whoosh. And then this one, turning on. This isn't the best example after all. Public void turn on. And what does turn on mean? It probably has control something, like whether it's enabled or not, whether it's moving or not, right? So Boolean turned on, which defaults to false, but turn on sets it to true. Now I wish I'd left it start, right? Because I hate the duplication of those words. So we're going to start our vehicle. And when we start it, we are in fact turned on. And so when we try to move, it may need to be more complicated than that. We may need to check to see if we have any fuel, and we may need to check to see if we're begun. So we're going to have a fuel indicator too. Yeah, just make a Boolean for now. Boolean fuel is equal to false. We don't have any fuel until we start to move. Until we refuel it. So that's one of the methods that we have to implement. Public void refuel sets that to true. Now maybe we should have, a counter that would, decrement the further it moved, but meh, let's go like that. Okay, so we have ability to turn it on, to engage the motor, to use up fuel. Well, we don't have a way to check our fuel. So if we're turned on, if not turned on, it's a problem, right? system.out.println, engine must be turned on. We're going to return false at that point. Yeah, that'll work. Which means that this would have to be a Boolean instead of that. Which means that this would have to be Boolean up here, whether we can move or not. The only time we can move is if we are turned on and if we have any fuel. So if not fuel, then it's a problem. I'm just going to copy these two statements to save some time. Engine must have fuel. Now, if those things are both okay, then we can return true. We're moving. Whoosh, moving. So now we have something called start, which turns our motor on. And we need one called refuel, which sets our fuel to true. And this was supposed to return a true if we actually got to move. What are you complaining about? Method refuel is already declared. Well, yeah, I guess I did up here. All right. Now we can have another kind of vehicle that doesn't have an engine. And so I guess it can just move no matter what. It's going to be a lot simpler. Class, I don't know, glider. It doesn't need all these things. It doesn't have to have a turned on and a fuel and stuff like that. All it needs is a move. Soaring we go. Return true. So down in main, if we create a jet, we're going to have to engage those preliminary steps of fueling it and starting the engine. And we could have made the start require us to have fuel, right? But there's no reason to make this more ordinary, more complicated than it already is. So we're going to make a jet. Lowercase j, uppercase j. Got it. For it to move, we have to turn it on and we have to refuel it. So refuel the jet, turn on the jet, and he's ready to go. Not turned on. I guess I called it start, didn't I? Start the motor. Now it's ready to move. J1.move. Now the glider doesn't need those preliminaries. It can just start moving immediately. Kind of neat. I guess it can just launch itself, huh? It doesn't have to be pulled into the air or anything like that. Right. And so this can also demonstrate polymorphism because we could create a method a fly, and all it needs to do is take an object that supports the move interface. So every vehicle takes a move. So our object here but I don't know if that's going to work. I should have created a class. I should have gone my original way and decided to inherit everything that had a class. And so I apologize for this, but I'm going to have to revise it so that everything is a vehicle. Oh, wait, he forgot to implement vehicle anyways. But anyways, extends vehicle. And this one needs to extend vehicle as well. Now, why are we getting an error there? No interface expected. I'm going to make vehicle in a class, an abstract class, rather than an interface. So the jet extends the vehicle and implements the engine. And then this is now an abstract class. No, it's not. That's still vehicle becomes our abstract class. And the reason we had to do that is because I needed to define some kind of type that both of those objects were so that I could pass it around into methods and stuff like that. So everything is a vehicle. And so everything can move. What are you complaining about now? Exporting non-public type to public. Okay, whatever. So we could create an array that had both of these things, or we could create an array list that had both of these things. You know, so vehicle fleet equals new vehicle with 2 items in it. Fleet subscript 0 is equal to our jet. Fleet subscript 1 is equal to our glider. And then we can call fly and pass in that array. Or, well, I didn't create it to make an array, but I could put a for loop down here that would do that, right? So for every vehicle V that is in the fleet, call fly and pass that vehicle in. And he's probably complaining because I didn't make him public static void. No. Create method vehicle fly vehicle in public static void fly. Public static void fly. Well, that's odd. I mean, it made it private rather than public, but honestly, I don't see the difference between this and what I had. If I change this keyword to public, yeah, what's the difference? I would have to copy and paste it. Okay, anyways, now we're exhibiting polymorphism because we have a vehicle, it can fly, right? All the vehicles can fly because they all inherit from the abstract class that has a promise that they will implement a move method. So this says that everything that inherits from it has to have a move method, and we have fulfilled that promise by having both jet and glider have that method. But we also have decided that certain things have engines, and so we created an interface, and if they implement that interface, they also have to have these start and refuel methods. Now we could conceivably create other classes, you know, like a car, and we could say that every jet can fly, but that not every car can fly, right? A car can drive, but they both can move, that kind of thing. But I think that's about far enough for this example. Let's go look at their example in the textbook. I guess I should run it. Are they both saying the same thing? Oh, yes, they are both saying the same thing because down here, I called move as we were creating them. And so the messages look identical. Now, if we wanted to be more awesome, what I probably would have done is make vehicle, this was my initial impulse and I was trying to take it in a different direction, right? Have a name and they have to take a name as the constructor. And so the constructor for a jet would need to call the superconstructor and pass in that it was a jet, and so on. I'm going to undo that, but that's probably what I would do. Where I would start taking it is figuring out what things our glider and our jet had in common, like maximum occupancy, that kind of thing. Maybe drones don't have any occupants at all, right? That kind of thing. All right. I'm still stuck on this from the last lecture. Protected x int x equals 3. Can we get a hold of that down in main? Can we say j1.x equals something? Yeah. Proving the textbook wrong. Proving all my years of knowledge wrong. When did Java do that? Why should you be able to get a hold of that? All right, anyways, fine. That directly contradicts what this slide says about what protected means. What does protected do? It's between public and private in access. Protected members can only be accessed by classes within the subtree. So it says, and we prove that wrong. Instead, protected now seems to be anything in the same package can get a hold of it. So I'm not going to even talk about it any further than that. This chapter doesn't talk about interfaces. I swear I thought it talked about interfaces. That's why I went into it. All right, so what is the name of the class? It's the superclass of everything, the object class. In the book, what two animal classes? Who cares? I like our examples better. All right, so that's our example. If I could think of some examples that this needs, what I would come up with is the idea if we're going to have object streams, if we're going to be able to write our file out to a file. And for that to happen, you have to implement something called, or you serializable. And if you add implements serializable, then you can use it with the object stream class. Well, let's see here. I don't think we've talked about file IO since Java 1, so what we're going to do is we need to bring in two classes called file output stream and object output stream. And those are just part of java.io. So let's just import java.io.asterisk. And so we want to create a class, I mean, not a class, we're going to create a file output stream. Equals new file output stream, and I forgot to capitalize the O there, and we're gonna fill in a file name, output.txt, or LectureV output.txt, right? Something like that. So file output, and what an object output stream is it lets you write entire objects to a file with one fell swoop, rather than writing out each individual piece of data. Now, there are drawbacks to doing file output, object output, rather than writing out the data one thing at a time, which is that, let's wait to talk about that until we actually go back and hit the chapter on file again, because I do want to next time give ourselves some examples of doing file I/O just as a refresher. And so then we need an object output stream that's built from that. Equals new object output stream based on that file. And then we could write our objects out, if we so choose. Do I have a typo? Yes, I do. And so we want to be able to write something to a file. Well, we better write something that can, has some data in it. Class data, and all it's got is a first name and a last name, right? Like that. It's enough. And so we're going to have to create an object in order to do that. Now, notice that we're getting these error messages because this is file I/O, and file I/O absolutely requires exception handling in order to compile. Because you have two kinds of exceptions. You have checked and unchecked exceptions. When a class is marked as throwing a checked exception, that means that the calling code, the client code, has to implement exception handling or it will not compile. So let's see what our little warnings offer us. Add a throw clause. Well, that's one way you can do it, is just, if you get that exception, you can throw it somewhere else to handle, but there's nothing that's calling main that we can get a hold of. And so we're not going to do that. Or we could surround the statement with try catch, or we can surround the block with try catch. Now let's surround the statement with try catch. And then we look here, but I'm also going to move this one in there as well. So we create our file output stream. We create our object output stream. May as well do that up here as well. So I'm declaring my objects outside of the try-catch block, because if you define anything inside a scope like that, it disappears when it's done, right? So OO is equal to new object output stream based on the file I/O. He wants his semicolon there. And this can throw a different exception besides file not found. So let's click on him and let him add his catch clause for that. So now we have two different handlers, right? We've got one that handles file not found exceptions, and we have one that handles just generic I/O exceptions. And I'm going to be totally lazy and just let this logger class handle it. Not quite the right way to do it. All right. So if I get to this point, I'm going to set these guys to null up here so that I can check to see whether they are null or not. So if we get down here and the object output stream is not null, then I can write my jet to the file. So if not equal to null, dot, and it has a whole bunch of write methods. You could just write individual things like ints and bools and things like that, or you could just write the entire object, write object. And we're going to take our jet, write it out to a file, and we get an error. The reason why is that a jet can throw an exception, write object can throw an exception, but that's not the only problem. But I guess we'll handle that one first. So we'll surround that with a try catch. Where's this close brace? Right there. Well, where's his close brace? Maybe I never wrote it. All right. Now this shouldn't compile because an object that needs to be written out as an object output stream has to implement something. It says it is not a serializable object. So it tried to run, but then at runtime, when we tried to print that object out, it complained that that object was not serializable. Serialized just means, you can store it in a file. You can write it to a file so that later on you can read it back in so the state of the object reconstitutes itself. Now, weirdly, and I don't quite understand this, honestly, and I've been doing this a long time, I just haven't researched it. All you have to do to get it to be able to be serializable is to add this. Implements serializable. Huh? Oh, not on move. I thought that was the class definition for some reason. I spaced out, right? And so implements engine serializable. That's enough to get it to work. All of a sudden, it knows how to write itself to a file by adding that. How does serializable work? Serializable is a mechanism of converting the state of the object into a byte string. The object serialized on one platform can be deserialized on a different platform. So take your object, write it out as a byte stream, store it in a database or in memory, and then later on, when somebody else wants to use it, they read it in and it becomes an object again. And so serialization adds whatever it needs that the object output stream class requires in order to do it. The advantages of serialization: it makes it really easy to save, to persist the state of the object and to travel across a network. Well, we haven't shown that, but you would just write it out in some form. You can write to a socket, an internet socket, just as easily as you could save to a file. It's just a different syntax for creating it. But an object output stream can be made both with a file reference or with a socket reference. Only the objects of these classes can be serialized, which are implementing java.io.serializable. It is a so-called marker interface. It has no data member and no methods. It is used to mark Java classes so that the objects may get certain capabilities. What capabilities? See, I don't understand how just marking it as serializable is enough. I guess maybe the object output class just checks to see if it is serializable, and it's just a switch, right? So if a parent class is implemented serializable, and then the child class doesn't need to implement it. So we could make it to where all of our vehicles are serializable and not just the jet. Only non-static data members are saved via serialization, not sterilization. Static data members are not saved via serialization. So if you don't want to save the value of a non-static data member, then make it transient. Well, that's interesting. Is that a keyword? Transient int, yeah, sure is. XYZ. And that marks it as something that is not serialized, so that it's written out to a file. That particular field is not written out. So if we want every object to be serializable, we wouldn't do it just to jet, although we could, right? We could just add that to every one of these. Instead, we could go up here to abstract class vehicle and do that. So this would need to be implement serializable. Now this stuff out here, down here, about writing our stuff out to a file, we could have probably have put this in a method instead, right? Public save data, public Boolean save data, which takes an array of our vehicles, right? So vehicle array, right? And it's going to do all this. It's going to take our file. I'm just going to do some cut and paste here. Whoopsie. All of that opens the file. So I'm copying and pasting that. Once the file is open, then we can write our stuff out. Oh, apparently I deleted a couple of things I shouldn't have about the jet. Got to cut that, move it back to main. And then we can, when we're writing our object out, we're not going to write, we don't have an object name J1. So we're just going to do for J1 in the array, right? So for vehicle J1 in the array, try and catch that. I mean, try that. But we're only going to do that if our object output stream is not null. And then we need to close our file. Need to close both of them. So oo.close, fo.close. Unreported exception. Well, okay then. Add a throw clause, surround it with a try catch. All right, and let's just put both of those inside here. Because heaven forbids we don't close our file correctly. Got to throw an error about that. There we go. Now what are you complaining about? Configure null pointer dereference hint. Okay, fine. If OO not equal to null, then allow ourselves to close it. And then if FO not equal to null, then allow ourselves to close it. Now, what I normally do and why I was tempted to ignore that is if I catch an exception trying to close it, I just don't do anything, right? And that way it wouldn't give me an error if I tried to access a null pointer, right? It wouldn't print anything out, but this is more textbook perfect, so why not? Okay, so we have the ability to save our data to a file by calling that method. So down here, after we're done flying, let's save our data. And what did I call it? Save data. I hope I made it an easy name to remember like that. Yep, and it takes that array in as a reference. Now it's more fun when this data is stored in an array list, because that means that you could write out a couple of members to an array, or you could write out a whole bunch of members to the array. And I guess save data works that way. Honestly, it does, because that code up there will step through every member of the array. So this is just as good. We'll just stick with that. So save our fleet. Non-static method cannot be referenced from a static context. Okay, I forgot to put the word static. So public static Boolean. All right, so there we have written a way to have our data be saved to a file. Well, what if we want to be able to read it from the file? Well, then we do a file input stream and an object input stream. But anyways, I guess that was a long way just to make the point, but we have added a whole bunch of functionality to our class just by marking them as being serializable. And let's go ahead and run it. Missing return statement. My original goal was to make it return true if it had saved successfully, and to make it return false if it hadn't. I guess I could still do that. I guess I could go up here and make a return value variable inside save data. Initialize it to false. And the only time we ever set it to true is after we have stepped through the array right here and written everything out. If we get to there without throwing an error, then we're all good. So set our ret val equal to true. And then down here, you know, we return our ret val, indicating whether we actually saved our data to a file or not. I guess strictly speaking, we shouldn't return true unless you get an error closing it, but I've never seen any problems along those lines. All right, let's build it, see if it builds now. All right, so when I run it, it printed our messages. It didn't display anything about saving it to a file just because I didn't put a print message here. But if I go out and I look for that file, I'll be able to find it. So I'm going to look for LectureV.java. Oh, great, I have way too many LectureVs. Well, I can make the name of that more interesting than just output.txt, right? I could call it LectureV output.txt. Run it again. Come on. Okay. Now maybe I can go out here and look for LectureV output.txt, see if it finds it. Well, I guess not. Maybe the indexing doesn't work that fast. Oh, it's searching recents. Search the whole Mac. Nope, not good enough. All right, let's find what directory our project is stored in. I'm going to come up here, right click on LectureV and choose properties. So I can check out. It's in the desktop LectureV. Okay, fine. So desktop LectureV. Output.txt, or that one. Now, if I double click it, it's not text. It's not readable. It's got all the information necessary to load this in as an object. Well, turned on is one of the members of our class, right? How about the other one, fuel? Yeah, there's fuel, right? And it's telling us that the object is of this type. It's a jet. And the other one should be a glider. If I look, there's another object called glider in it. And that one doesn't have a fuel or an engine thing written out. Now, like I said, you know, we can't really read it because it's not text. But there we go. So we have saved our file, and we could implement code that would read our file just as well. Now, since I didn't make it an array list, I'm not going to do that because we would have to worry about the length of the array. And maybe we could have written the array out as a whole. We absolutely could have. My write, my save data. Instead of having this for loop that printed them out one by one, saved them out one by one, I could conceivably have done this instead. Just write the entire array out in one call. It's also going to need a try-catch block around it, right? But I'm going to go ahead and do this part first. So write the object. What's the object? This time it's the entire array. And he's going to complain that I don't have try catch, so I'm going to surround the statement with try catch, right? And there we go. So if I wanted to write something that would read it in, all I would have to do is call read object to get it in. Considering it took about 20 minutes or more, which is kind of shameful, to get save data to work. Oh, let's do it. Public static Boolean read data. And what is it going to return? It's not going to return a Boolean value. It's going to return a vehicle array. And this file name business right here should actually be something that is passed in, right? So we should actually just make that a variable called file name and require that to be passed in as a parameter. Same thing for reading it. Now what are you complaining about? You just need to be saved. Oh, because I don't have a closing brace up here, it's going to complain about this line. All right, good. And so this one needs to take a file name as well. Excuse me. It's got to do the same kind of business, except it's going to create a file input stream and an object input stream. So let's create a reference to our array, because we'll need it later. Let's just set it equal to null so that I feel comfortable about it later. Maybe we'll need to return it and return a null value if there was an error there. So file input stream fi equals null. Object input stream, get down there. OI is equal to null. Now let's create our file. Reference is equal to new file input stream based on the file name. And it's going to complain because it does throw exceptions. So we're going to have to take care of that, but we'll do it in a minute. Well, why not do it now so that the next line of code we can do will be inside the block. So surround that statement with try catch. Good enough. And so object input stream is going to be based on that file input stream we created. So OI is equal to new object input stream based on the file input stream that was created. Now this one also wants the ability to throw an exception, which is just going to be that IO error. So add a catch clause for that. All right, now that it's loaded, we need to be able to read it in. We ought to be able to read it in one swoop. Now, the fact that it's an array confuses me a little bit because I've always done this with array lists, but let's give it a shot. We should be able to do this, that VEH array is equal to, I'm putting a couple spaces here for a reason, object input stream OI dot read object. That is a problem. What does this return? It returns a regular old object. Because how could read object know what a vehicle is, right? So it wouldn't know what to build and to return. However, we can cast it in our desired format. And what is our desired format? It's an array of vehicles. And it's complaining that it wants try-catch blocks. Surround the statement with try-catch. If we get to here, then everything is good, right? And so I could set some variable equal to success, but I'm just going to depend upon the fact that it was set to null. And then if this created it successfully, it's non-null. And so the last thing down here is going to be to return our vehicle array. So later on in some other code, if we wanted to read that array in and be able to process it, like the next time we launch this program, if we don't have any data, we might try to open a file and read it in. Then down here in main, we can do that. we have to pass in the file name here, right? So LectureV.txt, that's the name of our file now, all of a sudden. And so then, or alternately, we could read it in, ... So vehicle, VEH, or array2, excuse me, vehicle array, array2 equals, and we're going to call our read data method with that same file name. And if it's not null, then we could do that through it, right? So if array2 is not null, then vehicle for every vehicle, and for every vehicle in our new array, make it fly. So we'll just see the same message just twice. It'd be nice if save data printed out some kind of message, right, indicating whether it worked. So Boolean be okay is equal to that, and if it was okay, then print out success, right? If be okay, system.out.println data saved to file. And if we get to here and vehicle array is not null, then we can print out a message saying that the data was read from file. Read is one of those annoying words where the present tense and the past tense are the exact same word but pronounced differently. So anyways, right? We built our fleet, we sent the objects flying, and then we saved that array to file. And then we read a new array from file, and it was okay. So it printed out data read from file, and we sent that fleet flying as well. And we could transport that vehicle array using very similar calls, that .write object call over a socket, and probably other forms of communication medium as well. I can't think of anything other than file and internet, right? But maybe there's a database kind of class that could accept something like that. And as long as the thing had been marked serializable and it implemented whatever it needed to do to support write object, then it would work. All right, I honestly don't know where to take this anymore unless I was going to give the classic example of interfaces, which as being something that has, area and then something that has volume, right? I guess I don't need that anymore, right? So interface 2D, a 2D object has a get area method. So public double, public abstract double. I don't need to have the abstract word because it's an interface. Get area, doesn't need to do that. And we make one for 3D. And every 3D object has a volume. So public double get volume. And so a shape that implements 2D only has to implement get area. So a circle that can implement 2D we'd have to have our good old radius value, and then this method could calculate the radius, right? Excuse me, calculate pi times pi r squared and return it. So public double get area just needs to do that. Return pi r squared, so math.pi times radius times radius. Math.pi, I said. That should get rid of that error. Maybe when I save it, it'll figure it out. Oh, hasn't figured it out yet. Implements, excuse me. And then you could have another thing that implements a 3D object, or you could say that perhaps this is a 3D object, it just has a volume of 0. You know, some kind of circle that exists in a 3D plane, right? So how about another class called cube, and it's going to support a 2D interface. It has to be able to return the area, which is just the 6 times the side length for a cube. And so it implements both 2D and 3D. It's got a side length, and get area for it just returns 6 times the side length, right? Side length times 6, because the cube has 6 sides. Public double get area, and we could say return 6 times side length times side length. But it's a 3D object too, so we have to return the volume of it, which is just side length times side length times side length. Public double get volume. Return math.pow side length, comma 3. So if you create 2D objects, you know that you can call get area on them. If you create 3D objects, you know that you can call get volume on them. And some of them you can do both. Circle C1 equals new circle. Cube CU1 is equal to new cube. We can call get area on both of them. Double area is equal to C1 dot get area. Area is equal to CU1 dot get area. However, only one of them can get a volume. So double volume is equal to, can the circle have a get volume? No, it cannot, because it was not marked as a 3D object, so it has no volume. So C1 dot CU1 dot get volume. Alrighty, so that's more my classic example of interfaces, is coming out with that kind of thing, you know, geometric shapes, whether they have two-dimensional aspects or they have three-dimensional aspects. So obviously I didn't flesh that one out completely, didn't add constructors and stuff like that. I can't believe that chapter didn't talk about interfaces. It talked about abstract classes. Is that supposed to be the next chapter? Exception handling, which we should have covered way back, right? Anyways, well, it's chapter 16. Files, buffers, and channels. All right. Object output stream, file output stream, object input stream, file input stream. That's one way of reading from a file, but there are other ways. So we'll hit chapter 16. I think we already know enough about exceptions just from my examples here about them, honestly. I don't think we need to spend an entire lecture talking about them. So I think we've got enough homework. I want people to be working on their projects. And if I haven't given you feedback on your project upload form yet, I will do so very quickly. That should be done by tonight. And anybody who is listening, you have any questions over the material or anything else?
Can I get the Java file for this
Absolutely,
lecture?
yeah. Yes, I'm going to upload the notes. Will do. And hey, Lindy, I see you here too.
Hey, no questions right now, but I'll probably have more as I do my assignment.
All righty. All right. So yeah, I think that's enough. So let's end the recording.
All right, thank you.
Thank you.